Okay, write each expression in radical form or each radical in exponential form. 15 raised to the power of 1/2. 2 is the root and 1 is the power, if you will. So this would be, here, let me make this here. And let's make this a red pen. We can use it for marking up. There we go. So if we were going to write the index is the root. It's a little number that goes in the crook of the root symbol. This is the root symbol, and here's where the index goes, right here. Okay, the default index is 2. The invisible index is 2. So this is 15 to the first power, second root. Okay, 12y, quantity 12y to the 1/2. So we put that under the grouping. The grouping portion of the square root is this horizontal line called a vinculum. Okay, we put 12y under the vinculum and we do the square root. And again, this is 12y parenthesis to the second root. Okay, now we got a square root expression, and we're going to put an exponential form. So we got 2 times square root of a times b. We keep the 2. The 2 it's not affected by anything. Okay, it's apart from everything. So we leave the 2 by itself times the quantity a times b. The quantity ab is raised to the power of 1/2. The power of 1, root 1/2. Okay, so this is ab to the first. That becomes 1/2. Okay, 26. Now we're going to simplify this. The 5th root of 10 to the 24th power. Now, this is 10. I left out. I messed this up. Shouldn't be this way. Got a typo here. Oh boy. Anyway, 5th root of 10 of the square root of 1024. Sorry about that. I got the answer right, but I made a mistake here. We're writing out the problem. Okay, 1024 equals 2 to the 10th. Hopefully you know that by now. And which is the same as 2 raised to the 2nd power to the 5th power. 2 times 5 is 10, so that's 4 to the 5th. So we got the 5th root of 4 to the 5th. This is denominator, this is numerator. This goes to the numerator, and this goes to the denominator, which is 4 to the 5 over 5, which is 4 to the 1st, which is 4. And we're going to do this a whole bunch of times. Cube root of 0.001. Well, hopefully you can figure out that 0.1 times 0.1 equals 0.01, right? And then times 0.1 is 0.001. So 0.001 is 0.1 cubed. And we're taking a cube root of 0.1 cubed, so that's 0.1. This goes to the numerator, and this goes to the denominator. And we got 0.1 to the 3 over 3, which is 0.1 to the 1, which is 0.1. (64 to the 1/6). Okay, equals, all right, so 64 to the 1/6 is 2 to the 6th to the 1/6. So we've got 2 to the 6th to the 1/6, which is, this goes into the numerator. 6 times 1 over 6 is 6 over 6, which is 2 to the 1st, which is 2. 35, 1 over 81 to the 1/4. 1 over 81 is 1 over 3 to the 4th, or 1 to the 4th over 1 to the 4th over 3 to the 4th, if you will, which is 1 over 3 to the 4/4, which is 1/3. Okay, now we're going to have a little different wrinkle here. 38. 625 to the 3/4. Now, we're going to put it into radical form. 4 is the index, and it goes right there. And 3 is the power, and it goes right there. Okay?
No barking.
So, dog's barking. She's really got cabin fever. Okay. And you just can't take her out because it's too cold. Anyway.
No barking.
Now, what you want to do first is take the root and then take it to the power. You don't want to take 625 and cube it and then take the 4th root. Instead, you want to take the 4th root, if you can, of 625 and then cube that. And as you probably know, 625 is 25 squared, which is 5 squared squared, which is 5 to the 4th. So we got 5 to the 4th to the 1/4 cubed, which is 5 to the 4 over 4 cubed, which is 5 to the 1st cubed, which is 5 cubed, which is 125. Okay, 125. These numbers, same numbers are going to come up over and over and over and over and over and over and over again. So we got 125 to the 4th cube root. Again, take the cube root first. The cube root of 125 is 5. Everybody knows that. 5 to the 4th is 625. We just did that. Okay. 44. Okay. 8 over 25 raised to the power of 4/3. So we got 8 over 125 to the 1/3 raised to the 4th power. Okay. So we got 8. Now we're going to distribute this 1/3 to the numerator and denominator. We add 8 to the 1/3 over 125 to the 1/3 to the 4th power, which is 2 over 5 to the 4th power. So it's 2 to the 4th over 5 to the 4th, which is 16 over 625. $47. Okay, now we're going to got equations. 16 to the 8. Now, whole deal here. Here's the game. Make the bases the same. Okay? If a to the x equals a to the y. Oops, if a to the x equals a to the y, so the bases are the same, then x has to equal y. Also, we're going to do there's another version of this. If a to the x equals b to the x, then the bases have to be equal. So if you've got two powers with the same exponent, then the bases have to be equal. If you got two powers with the same bases, then the exponents have to be equal. Okay, so we're going to make the bases the same. Well, 16 is 4 squared. That's good, because we got 4 over here. Generally, you're going to make the bigger base try to be a power of the smaller one. But sometimes you have to change both of them. So 16 is 4 squared to the x equals 4. This is 4 to the 1st. So 4 to the 2x equals 4 to the 1st. So then, therefore, 2x equals 1 and x equals 1/2, and you can check it. 16 to 1/2 equals 4, obviously. Moving on. 30. Okay, so here we're going to change both of them. We're going to give them both base 2. Okay, 32 to the x equals 4. 32 is 2 to the 5th. Raised to the power of x equals 2 squared. 5x equals 2. 2 to the 5x equals 2 to the 2. 5x equals 2. X equals 2/5, and we check it. 32 to the 2/5 equals 4, definitely. 53. 6 to the x minus 4 equals 1296. And so I guessed that 36 squared is going to equal 1296, which it does, which means that 1296 is 6 to the 4th. So we had 6 to the x minus 4 equals 6 to the 4th. So we got x minus 4 equals 4. So x equals 8. And we check it, and it's good, and blah, blah, blah. Moving on. 56. 128 to the 3x equals 8. Okay, 128 is a power of 2. It's 2 to the 7th. 8 is 2 cubed. 2 to the 7th to the 3x equals 2 cubed. 2 to the 21x equals 3. 21x equals 3. X equals 1/7. And 128 to the 3/7 equals 8. Yes, it does. Okay, 59. 17 to the 1/3. We're just writing it in radical form. Equals cube root of 17. 62. Exponential form. Write it in radical form. M to the 2/3. Okay, the 2 is the power. The numerator is the power, and the denominator is the root. 2 times the cube root of a. Okay, the 2 is not affected by this. 3, this is a to the 1st. 1 is the numerator. And 3 is the denominator. And 68, the 4th root of n to the 4th over 16. So we got n to the 4th to the 1/4 over 16 to the 1/4. Okay, that's the 4th root, so we take the 4th root of the numerator and the 4th root of the denominator. I left something out here. 16 equals 2 to the 4th. So we have 2 to the 4th to the 1/4. So this is the numerator, that's the denominator. So we have 2 to the 4 over 4, which is 2 to the 1, which is 2. Okay, and meanwhile we got n to the 4 over 4, which is n over 2. So the answer is n over 2. 71. 8 squared to the 71. I think, did I write that right? 71. 8 squared to the 2/3. That's an exponent. It looks like, it doesn't really look like an exponent. Let me make that more exponential looking. To the 2/3. Okay. Now I'm going to write it. I'm going to put the root inside the parenthesis, which I can do because it's a multiplication operation. I can move the factors around. 8 times b equals b times a. So we got 8 to the 1/3 to the 4th power, because I don't want to square 8 squared. 8 to the 1/3 is 2. 2 to the 4th is 16. 74. 16 to the negative 2/3. So I'm going to take 16 to the 1/2 and then deal with the negative 3. 16 to the 1/2 is 4. 4 to the negative 3 is 1 over 4 cubed, which is 1 over 64. K, this one's pretty easy. K to the negative 1/2 is 1 over k to the 1/2. And we'll just leave it. Let's leave the answer like this. This is going to come later. That's called rationalizing the denominator. We're not going to get into that yet. We'll get into that later. I don't know when. I don't remember. I remember doing it last year with the freshmen, but I don't remember when. 81. Okay, now we're going to solve equations again. 81 to the 2/3 minus 3 equals 9 to the x plus 3. 81 obviously is 9 squared. So now we have the same base on both sides. 9 squared equals 9 squared to the 2x minus 3 equals 9 to the x plus 3. Distribute. 9 raised to the power of 2 times 2x minus 3 equals 9 to the x plus 3. 9 to the 4x minus 6 equals 9 to the x plus 3. And so now we make the exponents equal to each other. 4x minus 6 equals x plus 3. Oops, what did I do? 9, okay. 4x minus 6 equals x plus 3. 3x equals 9, x equals 3, and I check it. 83. 25 to the x equals 1 over 125. Make the bases the same. 25 is 5 squared. Okay. To the x equals 1 over 5 cubed. Well, we're going in the right direction. 1 over 5 cubed is 5 to the negative cube. If I'm going to switch these, then the exponent becomes negative. These two are equal. 1 over 5 cubed equals 5 to the negative 3 over 1. these two things here. Let me erase that. Let me write it like this. 1 over 5 cubed equals 5 to the negative 3 over 1. So I got 5 to the 2x equals 5 to the negative 3. 2x equals negative 3. X equals negative 3 halves. And I check it. Plugging it in, and it works out okay. 85. F. Okay, let's look at 85 here. Let's see if we got to do anything. Okay. So the frequency F in hertz of the nth key on the piano is, so the frequency is 440 times 2 to the 1 over 2 to the 112, raised to the power of n minus 49. Interesting formula. Don't know how they got it, but it's kind of cool. So, what is the frequency of concert A? Well, concert A is n equals 49. So the frequency of 49 equals 440 times 2 to the 112th raised to the power of 49 minus 49, which equals 440 times 2 to the 112th raised to the power of 0, which is simply 440 times 1. So the frequency for 49, which is concert A, whatever the heck that is, that's up for you music guys to know what that means, is 440 hertz. Now, which note has a frequency of 220 hertz? 220 equals 440 times 2 to the 112th times n minus 49. So we're solving for n. Isn't that fun? Isn't that special? Okay, this looks like an impossible thing to do. We talked about this at the beginning of the chapter, but here it is. 220 over 440 is 1/2, so that's convenient. Times 2 to the 112th times n minus 49. Okay, that's one heck of an exponent. Now, we're not going to distribute that 1/12. That would be painful. We don't want to do that. Okay, instead, what we're going to do is we're going to make the bases the same. 1/2 equals 2 to the negative 1. Okay, we've been through that. This is old territory here. So therefore, we have an equation of negative 1 equals 1/12 times n, the quantity n minus 49. Multiply both sides by 12. We get negative 12 equals n minus 49. N equals 37. So it's whatever that is, the 37th note. Hopefully one of you really talented people knows what that is. 88A. Here, what's 88 all about? Okay, we're just filling in the table here. So, 88A, x, and then 4 to the x. That's x and f of x. F of x is 4 to the x. Okay? So, if x is negative 2, f of x, 4 to the x is 1/16. Negative 3 halves, 1/8. Negative 1, 1/4. Negative 1/2, 1/2. 0, 1, 1/2, 2. 1, 4, 3 halves 8, and 2 is 16. Okay, good little exercise there. And here's what the graph looks like. It's asymptotic. That means the left side of this, as x approaches negative infinity, y is going to approach 0, but it's never going to reach it. I mean, I know my line is like crashing into the x-axis here. That's because I've got a problem here. This is exponential growth, and so it's hard to come up with a scale that's going to work on this. So, but the x-axis goes from negative 2 to 2, so you can see the scales are different on the axes. But each square going vertically counts for 2. Each square going horizontally is only 1/4. All right, and so its curve grows exponentially. Graph curved as x approaches negative infinity, y approaches 0. As x approaches positive infinity, y approaches positive infinity. Okay, as x increases by 1/2, y doubles. 91. For what values of x does x equal x to the negative 1/3? Well, 1. Okay. 1 to the negative 1/3 is 1. Negative 1 to the negative 1/3 is negative 1. And 0 to negative 1/3 is 0. So there's 3 values. 94. 16 to the 3/4 plus 9 to the 3 halves. 16 to the 1/4 cubed. Okay, 16 to the 1/4 is 2, cubed is 8. 9 to the 1/2 is 3, cubed is 27, 35, which is D. 96. 2L plus 2W equals P. 2 times W plus 9 plus 2W equals 52. Let's look at 96 here just for the heck of it. We got a little picture here or something. Here we go. Find the dimensions of the rectangle's perimeter is 52. So 2L plus 2W equals P. 2 times W plus 9 plus 2W equals 52. W ends up being 17 over 2, which is 8.5, and then L is going to be 9. Add to that, 17.5. 99. What's 99 all about? It's just simplification, it looks like. C to the 8th over D to the 11th. C to the 8 minus 4 over D to the 11 minus 5. C 4th. D to the 6th. We're doing a square. Pretty self-explanatory. 9 M to the 8th over 16 P to the 4th. 105. Put it into y equals mx plus b form. Not too much to say there. Same thing. 111. These are self-explanatory. And that is that.